Hey everyone, I hope you enjoyed your day off yesterday. I'm sure you spent it all reviewing Unit 6, which we just finished. So now we're going to dive into Unit 7, and we're starting off with properties of quadratics. So a quadratic equation has an exponent of 2, and a graph is a parabola. What that means when we have an exponent of 2 is that equations for quadratic functions will look like this. Y equals x squared plus 3, something like that, where our exponent here on the x is a 2. All right, so on these notes we have a couple of graphs, and at the bottom we have a lot of definitions. So we're going to go look at these definitions, and as we go through them, we will find those different things, those different properties on each graph. So our first word here is our y-intercept, something that we are very familiar with. So just as a review, the y-intercept is where the graph crosses the y-axis. We know that the y-intercept always is in the format of 0, comma, and then whatever the number is, then the value of that y. Okay, so if we look at these graphs up here, the first graph we're actually going to see, we have our y-intercept is right here at 2. Okay, so if you put a point right there, this is our coordinate for our y-intercept, so we'll write it as 0, comma, 2. The next graph, in this picture actually we do not see the y-intercept. It will eventually cross the y-axis, but we just don't have it in our view here, so we're just not going to write our y-intercept for this graph. All right, our next vocabulary word, this one is new, is the vertex. So the vertex is the highest or lowest point on the graph. Sometimes when we talk about the vertex, we say that it's at the turning point, meaning the graph may be increasing and then turns to decreasing, or decreasing then increasing. So let's look at this graph up here. The first one, notice if you're looking left to right, it's decreasing, and then it turns to increasing. So right here, actually at our y-intercept, is where the vertex is. So the coordinate at that vertex is also going to be 0, comma, 2. On our next graph, as you look at it from left to right, it is increasing, and then it's decreasing. So right where we have that turning point, the highest point on our graph here, that is the vertex. And when we write the coordinate, you look at what the x value is there and the y value, and that coordinate is at 4, comma, 4. All right, the next thing we have are solutions, zeros, and x-intercepts. These are really all words that mean the same thing, and we know what an x-intercept is, so we just need to know that zeros and solutions are the same thing. So this is where the graph crosses the x-axis. And when we write these coordinates, you're always going to have the x value first, and then a 0 for y. So we'll look at our first graph here. Our x-axis, remember, is the horizontal axis. It's right here. And our graph will never cross the x-axis. So we have no solutions and no zeros, which remember are the same thing. So if we look at the second graph, notice that it does cross the x-axis, the horizontal axis, in two different places. Once when x is 2, and the other one when x is 6. So when we write out these x-intercepts, we always put the x value first, 2, 0, and 6, 0. And zeros, same thing as x-intercepts or solutions. We have 2, 0, 6, 0. Those are the coordinates of our x-intercepts, zeros, and solutions. All right, so next we have the axis of symmetry. So the axis of symmetry is a vertical line that divides the graph into two equal parts. Divides the graph into two equal parts. And since it is a vertical line, that means it does have an equation, and that equation will always be an x equals some number equation. And when you think of symmetrical things, you know there are shapes that are symmetrical. So for example, a circle is symmetrical because I can draw a vertical line straight down the middle, and if you were to fold that in half, it would be equal on both sides. Okay, same thing with a square, a rectangle, or a heart. If you fold them right down the middle, it's equal on both sides. So we're going to do the same thing with what we have on our graphs here. All right, so when you look at these graphs, you want to look at a line that's going to divide them into two equal parts. And the good thing for us is that line will always go through the vertex. So remember, the vertex is where we put that green dot here. So our axis of symmetry will go straight through our vertex, and it's a vertical line. So when we write out the equation, it's x equals, and you put the x value that it's going through here, and on this graph it's x equals 0. On the other graph, we'll look at a vertical line that goes through the vertex as well to show our axis of symmetry. And so we look at a vertical line that goes through this green point. Okay, so that's where our axis of symmetry is. It's again going to be an x equals equation. And this time our x value that this line goes through is at 4. So the equation is x equals 4. Next, we're looking at the maximum and minimum. So we just want to be able to identify whether a graph has a maximum or it has a minimum. And sometimes it even asks us, what is the y value at that maximum or minimum? So the maximum is just the highest point of the graph. And then the minimum is the lowest point. And if you're ever asked for the y value at the maximum or minimum, You just give them whatever y value is at that point. So let's look at the first graph here. We want to see if it has a maximum point or a minimum point. Notice that these two lines, if you keep looking at the top, they're going to keep on going up and they're not going to stop. So that means there's not going to be a highest point because it will keep on going up. But there is a lowest point, and it's going to be right up where that vertex is as well. So right here is our vertex where the y value is 2. So we do have a minimum point on this graph. Now if we have a minimum point, that means our graph is opening up. You can think of it as up like a cup. On the next graph, we'll look at if we have a minimum or a maximum point. And this time, notice that there is a highest point, because if you follow the graph, it's going to have a turning point right where y is 4, and it's also going to be where your vertex is. So since it's not going any higher than that point, that means we do have a maximum, and it's opening down. So it is down like a frown. So if your graph opens up, you know you have a minimum, it's up like a cup. If your graph opens down, you know you have a maximum, it's down like a frown. And our last vocabulary word here is parabola. So parabola is what you're going to hear a lot. Parabola is the shape of a quadratic function. So the parabola is that U shape that a quadratic function makes. When I go to soccer games and I watch my students kick the ball down the field, that makes that U shape, and I like to yell, "Wow, look at that parabola." So if you notice, if you look at these two graphs at the top, they both have that U shape, and that is our parabola. So that is our introduction to quadratics, looking at key properties.